Unlike the last problem where we tried to solve for x and there was just one x inside the radical, notice here when we go to try to solve for x, there still is only one x in the radical, but there's another x in the problem. Anytime that there's more than one x in the problem, we want to try to get them together if we can, but because one's inside the square root and one's not, it's going to cause us a little bit of trouble. So what we need to do first is get this x out of the square root before we can do anything. In order to do that, I'm going to minus 3 from each side. That's going to get the radical by itself on the right-hand side of the equation. So I end up with the square root of x minus 1. At this point then, what I'm going to do is I'm going to square both sides of the equation. The square and the square root will undo each other and leave me with just x minus 1, which is great. So that's going to get the x out of the square root. On this side, however, notice I've got x minus 3 squared. Be really careful. Remember, x minus 3 squared means x minus 3 times x minus 3, and we're going to have to FOIL or distribute those terms all the way out. When I go through and do that, I'm going to get x squared minus 3x, and then when I multiply that out there, I'm going to have another minus 3x plus 9. And so after getting the radical by itself, squaring both sides, and distributing and combining like terms, I end up with this bigger equation. Notice I still have an x squared in my equation, and I also have a plain x. Now, anytime that you have a squared and an x in the problem, you want to start thinking about using the quadratic formula or factoring in order to solve. Either case, we need to make sure that one side of the equation is equal to 0. I'm going to move everything over to the left side. So there's an x, so I'm going to minus x from each side. There's a minus 1, so I'm going to plus 1 from each side. On this side, that gets me the 0 that I would need in order to do the quadratic formula or factoring. On the right-hand side, I had an x squared. This minus 6x and minus x will give me a minus 7x, and the plus 9 and plus 1 is going to give me a plus 10. At this point in time, generally what I'm going to do is I'm going to spend just a couple of seconds here and see if I can find a factoring pair that works, and if I can, then I'll keep going, and if not, then I'll switch over and use the quadratic formula. To get x squared, it's x times x. To get 10, I can try 2 and 5. And because that's a minus 7, we can try minus 2 and minus 5. Do a quick double check. X squared minus 5x minus 2x gives me the minus 7x I need, and negative 2 times negative 5 gives me a positive 10. So that factoring worked pretty good. That solves the problem a little bit faster. Don't forget, you could, in fact, go back and use the quadratic formula. A is using a equals 1, b equals negative 7, and c equals 10, and you'd get the same problem, or the same solutions. Now that we've got a factoring problem equal to 0, because 0 is such an awesome number with multiplication, that means that one of those factors would have to be 0. So we can solve each of those equations. We get x equals 2 as one possible solution, and x equals 5 as one possible solution. Now, what we aren't sure about is, are both of these actually answers? Remember, at this point here, we squared both sides of the equation, so that means that we introduced the possibility of having some extraneous roots that don't actually work in the original problem. You do need to check both of them, because it's possible that both answers do work, or only that one works, or that none works. So let's try them both. Let's start with checking x equals 2. So I'm just going to go through and rewrite my original problem. Anytime I see an x, I'm going to put 2 in instead. So I want to see, is 2 equal to the square root of 2 minus 1 plus 3? Well, let's see. 2 minus 1 is 1. The square root of 1 is 1, and 1 plus 3 is 4, which is not equal to 2. So that means that x equals 2 is not a solution to this particular equation. Next, let's check x equals 5. That was our other possible. So we go back to the original equation. We put 5 in anywhere we see x. So 5 equals the square root of 5 minus 1 plus 3. Let's see if this one works. So 5 minus 1 is 4. The square root of 4 plus 3. The square root of 4 is 2. 2 plus 3 is 5. Yay, that one works. So in this case, x equals 5 does end up being a solution to this equation. X equals 2 was an extraneous solution that was introduced because of the problem-solving process. And that's what you would need to do. Actually make sure that you check both of those answers so that you know that one of those answers is not valid in terms of your